In power systems, many theorems from electrical engineering and circuit theory are applicable. These theorems are essential for analyzing power flow, stability, and optimization in electrical grids. Below is a list of the key theorems involved in power systems. Let us discuss top 100 of these theorems, laws and formula. Ohm's law: the current through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. Kirchhoff's laws: current law KCL, the sum of all currents entering a node or junction is equal to the sum of all currents leaving the node. Kirchhoff's voltage law KVL, the sum of the electrical potential differences voltage around any closed network is zero. Thevenin's theorem: any linear electrical network with voltage and current sources and resistances can be replaced at terminals A and B by an equivalent voltage source in series with a resistance. Application in power systems helps simplify networks for easier analysis of power delivery, fault analysis, and load calculations. Norton's theorem: any linear electrical network can be replaced by an equivalent current source in parallel with a resistance at terminals A and B. Application in power systems. It is often used for simplifying complex circuits in fault and load flow studies. Maximum power transfer theorem: a load will receive maximum power from a network when the load resistance is equal to the Thevenin or Norton resistance of the network as seen from the load terminals. Application in power systems ensures that loads are matched to the system for optimal power transfer, such as in transmission line design and transformer sizing. Superposition theorem: in a linear network with multiple independent sources, the current or voltage at any point in the network can be found by algebraically summing the contributions of each source acting independently, with all other sources replaced by their internal impedances. Application in power systems, useful for analyzing networks with multiple sources, like generators in a power grid. Millman's theorem: in a network of parallel branches, each branch with its voltage source and impedance, the voltage across the parallel combination can be found by a weighted sum of the voltages divided by the sum of the conductances. Application in power systems, often used for simplifying the analysis of parallel circuits in power distribution. Telegen's theorem: for any electrical network, the sum of the power delivered by all sources is equal to the sum of the power absorbed by all elements. Application in power systems, important for energy conservation principles and power balance in a network. Load flow theorems and algorithms, Gauss-Seidel method, an iterative technique to solve the power flow equations in a power system. Application, commonly used in power flow studies to determine bus voltages and power flows in large networks. Newton-Raphson method, a more efficient and faster converging iterative method for solving nonlinear power flow equations. Application,